I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, or CSIAC. Today's presentation is entitled Secure Software Development Considerations. My name is Steve Warzala, and I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked anytime during the presentation by utilizing the chat function, and time permitting, your questions will be answered at the end of today's session. The briefing slides will be posted on our website within a few days after the presentation today. And finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Dr. Thomas Dube. He is a Senior Cybersecurity Analyst at Assured Information Security. Previously, Dr. Dube was an Assistant Professor of Computer Engineering and taught graduate courses in Operating Systems, Software Assurance, Reverse Engineering, and Computer Networks. He has a master's degree in Information Assurance and received his doctorate in Computer Engineering. I will now turn the presentation over to Dr. Dube. Good afternoon, Tom. The floor is now yours.
Thank you, Steve. Today we're going to talk about secure software development considerations, and without any further ado, let's go ahead and go over today's agenda. So I am Thomas Dube, as Steve mentioned, and we'll talk about secure software development considerations. So we'll cover some background. We'll go over some terms that may or may not be you may or may not be familiar with. Define secure coding. We'll define vulnerabilities within the context of what we're of secure coding. We'll talk about some sources available. We'll talk a little bit about one example of a vulnerability called command injections. And when we do that, we'll, of course, define them, discuss what they are. We'll discuss why you hopefully should care about command injections. And we'll also discuss, since we're introducing a vulnerability here, we'll also discuss how to mitigate those particular vulnerabilities, which is, of course, common interest once you understand what a vulnerability is. And then we will follow that same outline with a real-world example that was published recently in the last year. And that'll be kind of our case study, so to speak. We'll go through that and we'll explain why the example code is vulnerable, what can potentially be done with it, and how to mitigate that particular vulnerability. And then we'll talk about some of the considerations as we go through this, hopefully to glean some extra insight here. Okay, so first of all, what is secure coding? There's a lot of conflicting definitions out there, or they're not necessarily too conflicting, but they focus on different aspects of secure coding depending on the author of the particular definition. But it's basically the practice of developing software that's free of security vulnerabilities. You know, a lot of people don't necessarily see the inherent value in writing software that's free of security vulnerabilities until it's too late. For instance, if I'm writing a web application that I suspect not too many people are going to be interested in trying to exploit, once that is actually exploited live, I tend to lose a lot of credibility with that particular application that I had developed that was vulnerable, because I wasn't anticipating that there are people out there that, for whatever reason, whatever their motivation is, would love to see this particular application fail in whatever way possible. Typically, when you start talking about secure coding training, there's two common presentation formats that I've used in the past. There's best practices, which basically explains how to code defensively. So in other words, when you're getting ready to take user input, make sure you do these particular checks with it. And then there's also vulnerabilities or vulnerability-centric presentation format as well, which doesn't necessarily teach you how to code defensively, but it definitely teaches you why you need to code defensively, because you can understand just how easy it is with some of these vulnerabilities to actually cause an exploit condition. And so the best application for training for secure coding is probably a combination of these two presentation formats, right? Best practices and vulnerability understanding and research. But that's neither here nor there. We'll talk about this as we go. So it's very much like the analogy of defensive driving, right? So it's learning how to code defensively and also learning why you want to code defensively. So very, very good analogy with defensive driving. Okay, so what is a vulnerability? A vulnerability is a system weakness that an attacker can potentially exploit to gain an advantage. To kind of illustrate that, I've got a couple of graphics here. The graphic on the left is an old castle gate that obviously is in disrepair and obviously isn't really serving as much of a defensive measure anymore. But I'm sure back in its day it was probably rather illustrious and very effective. But what you can see here with this particular system, if we were to look at this and say, oh, this is supposed to be a security component or a security system, we can see that this particular system on the left has several weaknesses. For instance, it's wide open, it's not secured, it's not locked, and if it were shut, if the gate were actually shut and locked, it also doesn't look like it'd be too hard to just climb over, right? Another glaring weakness is, of course, that there's no walls that are abutted up against the side of the gate, so you could actually just walk right around the gate even if it were locked and even if there were a guard posted there. Another weakness that you might not notice is you've got this, because this is actually the inside of the gate that we're looking at. So if anybody were interested in trying to force their way through the gate with like a battering ram or something else, they can come down that nice trail there and get a little bit of momentum built up and potentially subvert the gate's integrity, right? So when you contrast that, this would be a very weak system in today's standards, right? And we certainly don't want our software applications to resemble that gate there on the left. What we'd really like to do is we'd really like to have our software systems look like the formidable castle that you see over on the right-hand side. And when you look at that particular gate, you notice that there's a lot of things that are better prepared for defense than the gate on the left. For instance, that long trail that we were just talking about that somebody could try to run a battering ram through, not going to be as easy with this castle over here on the right because this castle is actually on a mountainside. And so if you were to try to get access to the gate, you have to negotiate that 180-degree turn essentially coming around the corner, which wouldn't be as effective. The other thing you notice is that there's plenty of defensive emplacements along the gate on the right. So you've got the towers, and you can have lookouts, and you can imagine, you know, if this were medieval times, you could have archers and a bunch of other defenses up there on the top of the castle walls there and the towers. And of course, the gate is actually shut and secured as well. So this is really what we want our software applications to start looking like in our software systems, right? We want to start resembling the castle on the right-hand side here with those defenses. Okay, so a couple of resources that are out there that are publicly available. I highly recommend you take a look at some of these resources. The first would be the National Vulnerability Database, which is a pretty good government repository of vulnerability data. I think at the last check, I think it had about 75,000 vulnerabilities posted in this National Vulnerability Database, or NVD. And it typically, for each vulnerability, it will list what we call the Common Vulnerabilities and Exposures, or CVE data. Well, the CVE data is essentially, well, first of all, there's an identifier that's a unique identifier that lets you talk about a specific vulnerability for a specific application. So if there were a couple of different organizations that were trying to discuss vulnerability research or vulnerability efforts, this particular identifier would be useful to say, hey, I'm talking about this particular vulnerability in this application, because an application could potentially have multiple vulnerabilities, right? And also that was posted at this particular time. So with the example CVE number that I have listed here, CVE 2015-5082, this particular vulnerability is from 2015. And as you can see, they had over 5,000 vulnerabilities listed in the year 2015. And, additionally, the CVE data will include a description which talks about the type of vulnerability, the potential impact the vulnerability may have. So, for instance, does it lead to disclosure of information? Does it lead to a loss of availability? Does it lead to a loss of data integrity? And it'll also talk about the access level required in order to actually execute a particular vulnerability, or excuse me, to take advantage of a particular vulnerability to exploit it. The Common Vulnerability Scoring System, CVSS, is basically a framework for rating vulnerability impact. The numerical ratings range from 0 to 10, with 10 being the most severe. So this is kind of a way to quantify what the impact of a vulnerability would be, which is can also be very useful. Okay, so let's talk about command injection for a few minutes. Command injection is basically an attack where the goal is to execute arbitrary commands. There may be a system where you expect a particular type of input to come in as data, but command injection is basically inserting what is typically called like a meta character, which is a special character that changes the context from data to execution or another command or a shell command. And so the idea here with command injection is you try to execute arbitrary commands by passing, or when an application passes unsafe user-supplied data. So when the user gets to enter particular pieces of data, they can include some of these characters, which is not a passive shell. So when it passes to a system shell, all a system shell is, you can think of it kind of as a command prompt. But it's just a way to invoke operating system services or service applications. And here's an example of a command injection vulnerable application or vulnerable script here. This is actually a Perl script, and I apologize for throwing code up here on the slides. I know some people are probably a little nervous. But the command injection example here, if you look at the last two lines, it's really where the vulnerability exists. So the path is basically taken as a command line argument. So I would punch in the name of this script, and I would pass an argument to it on the command line, and the path is taken in. And notice that nothing happens to that. That's the user-supplied portion of the input, and it gets blindly copied into this string, which is passed to a system shell. And that string is to execute the cat command. All the cat command does is essentially just dumps out the contents of a file. And this is an example of a system that would pass unsanitized user-provided input to a system shell. That system shell is actually invoked by the system call there, the system with the open parentheses bin cat path. So this is actually what the output would be with this particular, or what the output could be with this particular command injection. I've got a particular folder here, CSIAC, right, and I list the contents of that particular directory with the ls command. You can see important.txt, and then I've got the actual Perl script in there. That's the script that we just looked at on the previous slide. And the .txt file is essentially just going to have the text test inside it. So if I were to dump the contents of that file out, it's just going to say test, which is what it says on that very next line when I invoke it and I pass it the test.txt file. So that's an example of correct execution of that particular script. So a normal functional operation of it. But the problem is a user doesn't have to necessarily use that in the way that it was intended. So I can, as a user, I could potentially insert a semicolon into that particular input. So it's test.txt with a semicolon. And that would basically tell the command shell that, hey, I've got another command that I'd like you to execute afterwards, right? And so the next command that I'd like you to execute is to actually remove that important.txt file. And then I have another command I'd like you to execute afterwards, and that's to list the directory contents again. And as you can see, there's two different outputs from this particular Perl script when we run it this time. Now we see test, which is the dumping of the test.txt file. But then the next output is actually, the second output is actually showing the directory contents, but that important .txt file is missing because it was removed. So this is an example of where the system passes that unsanitized input to a system shell and the type of impact it could potentially have. Okay? So why should we care about command injection? Well, first of all, command injections are very, very simple attacks to execute. As you saw from the last slide, I can show you on one command line argument how easy it is to actually execute this particular attack. But depending on what the commands are that we pass to it, it could have a very critical impact on security. And attackers and nefarious users would have a very good insight onto what they would want to pass to that particular command shell in order to have these kinds of impacts. But just as it's a simple attack to execute, it's also a very simple attack to defend against. So if you looked at the National Vulnerability Database, if you look at the most critical vulnerabilities related to input validation from 2011 to 2015, you would see that injection attacks are actually about a quarter of all the attacks in that particular category, in that particular subset, which is a very substantial number, with input validation vulnerabilities also being one of the much larger classes of vulnerabilities in that database. Okay. So that's the vulnerability. So how do I go about mitigating that particular vulnerability? Well, typically what you're going to do is you're going to perform what's called input validation. And that is a couple steps to it. First of all, we're going to define some requirements for input. And then whatever that happens to be, and then we're going to go ahead and enforce those requirements to make sure that the data that comes in matches our expected requirements and doesn't deviate from those requirements at all. So as a simple example, let's talk about a hypothetical user account information form for a web application. So if there's an age field in that particular form, should we allow letters in that particular age field? Probably not. Most people don't have don't express their age with letters, although you could potentially spell out a number, right? The other question is, should we allow punctuation in an age field? Other than potentially some engineers or scientists that wanted to give you a very precise value of their age, there really wouldn't be a whole lot of need for periods in the age field or commas. For some locales, I guess they use commas instead of periods, right? And there probably isn't a whole lot of need for question marks and exclamation points, etc., in the age field. So these would be examples. Those first two questions there are examples of trying to define specific bad things that you might want to restrict from an age field. Okay, so it's basically saying you can put anything in that age field except for letters, or you could put anything in that field except for punctuation. And that's what we call a blacklist approach, or a negative security model, which is basically saying you shouldn't do this type of thing. Oftentimes, it's a lot easier and safer to define what the user can actually do rather than what they can't do. So if you look at the last example, in the last example, our requirements would essentially be we're only going to allow numbers from 0 to 120 for an age field. We're not going to allow any numbers outside those particular ranges. So not only does it say, yeah, we're going to allow numbers, but it also gives a particular bound on the range of numbers, which is potentially more suitable. Now, of course, if you've got customers that you would expect to use this that are 121, they might be offended, so maybe you'd want to go up to 150. I don't know. But it depends on the application. Okay, so here's an example of a mitigation for that previous script that we talked about, the new cat command. In this particular case, I'm going to use what is called a regular expression to restrict that path argument to the POSIX fully portable file name character set. The fully portable file name character set basically just allows letters and numbers, periods, underscores, and minuses. And of course, it's case independent as well. And to accommodate paths, I've included the slash as well, the /, right? Because it's a Linux environment here that we're talking about. And so all this regular expression is basically going to do is it's going to check from beginning to end of that user input, ignoring case, and it's just going to make sure that I'm using letters, numbers, and those 4 acceptable symbols and nothing else. It won't allow any other symbols or characters to be used. And if you do happen to match, if you don't match that particular regular expression, so in other words, you're using something that wasn't expressly allowed, I'm going to say that that's a non-portable character in the path, and I'm going to exit. The last thing I want to do if you use something that I don't allow is to actually go ahead and pass that to that system shell, right, that system call. And we'll see an example now of how this actually works. This is the same setup as we had earlier, where I've got that important.txt file in the same directory. We've got the new cat. It's actually the modified cat file now. And we've got the test.txt file. And when we do that same functional test, right, where we dump that test.txt file, we see that it still has the correct or intended functionality from originally planned. Because we don't want to change that. We don't want to ruin that, right? Because that's what the script is supposed to do. We expect it to do that. But now also notice that it has a much more robust security aspect, because as soon as I try to do any kind of inject here, where I insert one of those meta characters that we were talking about, that changes the context from data to a second instruction, for instance, it immediately pops out and says, oh, I see something in there that's not allowed, so that's a non-portable character, and it doesn't do anything. And that important.txt file is still actually in the folder. I probably should have shown that in this particular example. But the point is the command injection attack does not work. It fails at this point, because we are defining specifically what is allowed to run, and if you violate that particular allowed character set, which is referred to as a whitelist, it will fail to execute that. Okay, so let's try to put this all together again here. So here's a real-world example of command injection. This occurs with the Endian Firewall Community Edition, which I'll call EFW from here on, and it's version 2.5.2. This particular firewall version is actually, I think, the one generation old from the new version. I think the newest version is version 3, and I think this is the previous version of this particular firewall. So we see that CV number 2015-5082, the one that I referenced earlier, just for consistency. This is a vulnerability that was posted back in September of 2015. You can see the information there. Original release date, September 28th, 2015. And it came from the U.S. Computer Emergency Response Team and the National Institute of Standards and Technology. And you can see here that the Endian firewall allows remote attackers, in the description here, it allows remote attackers to execute arbitrary commands via shell meta characters, which is what we talked about before. In the case that we described earlier, it's the semicolon character. Meta characters basically just means a special character that has a special meaning. And in the case of command injections, that special meaning is essentially that it's going to change from a data context to a command context. And it even gives you the two particular parameters that are vulnerable to these command injection attacks, as well as the particular script that's also vulnerable to the particular attack. So let's go ahead and look at the additional information. Now, okay, so this was from the National Vulnerability Database, this information. And this is a specific CVE that was noted in that particular vulnerability database. There are vulnerabilities associated with particular tools, particular applications, and you can have multiple vulnerabilities in the same application. You can have no vulnerabilities in the application. In that case, there won't be any entries. But with each one of those CVEs, there's also going to be some CVSS scores, so the vulnerability scores from 0 to 10, basically for different aspects of the vulnerability. And these are this is the impact section, essentially, of the command injection attack that we were talking about, the vulnerability that's described in the National Vulnerability Database. So with these scores, one thing to notice here is these are the highest scores possible. So the base score is essentially 10, which says that it's a very significant vulnerability. The impact subscore, which is how it's going to impact the triad of information assurance, if you will, the confidentiality, integrity, and availability of the system, it's a 10, which means it's the most significant impact to that particular vulnerability, right? And then it also has an exploitability subscore, which kind of describes how easy it is potentially to exploit. And again, or likelihood of exploit. And it's the highest value that you can receive, again, because it's a 10 on the scale of 0 to 10, which basically says, there's a high likelihood that this attack will be exploited, this vulnerability will be exploited, because it's just such an easy vulnerability to exploit. And you can see the metrics down below. You can see that it's network exploitable, which is perhaps even worse, because what that means is I don't have to be local to the system to actually exploit it. I can exploit that particular vulnerability from a remote system. And then access complexity. It's a very low access complexity, which means that it's very easy to actually exploit this particular vulnerability. So this is like the worst of the worst. Okay, this is about as bad as you're ever going to see one of these CVSS impact scores here and metrics. To make matters worse, though, if you look at the authentication field, it says not required to exploit, which basically means you don't even have to authenticate to the particular system, to the Endian firewall version 2.5.2, in order to actually exploit this particular vulnerability, which is exceedingly dangerous, right? Because this isn't just trusted users at this point. This is essentially anybody who can talk to that system at all. Excuse me. And you can see the impact types there at the bottom too, as well. And it describes how this particular vulnerability be able to violate confidentiality and also violate integrity, so unauthorized data modification, and also disruption of service, so impacting availability. Now, the one thing that even when you see the vulnerability scores here, this is a very significant vulnerability because for this particular system. Because when you think about what this system is, this is an Endian firewall community edition. So this is essentially an open source firewall. They have commercial versions of this as well, incidentally. But this particular firewall is intended to be used as a security tool. So this is a tool that's supposed to help protect the network perimeter. And if I can basically destroy the integrity of this particular firewall remotely, that's a very substantial vulnerability, and one that I would certainly hope to be able to address. So in this particular case, I would say that this is very significant because it's a critical network security component, and what we've described here on these vulnerability scores is that it's exposed to remote complete compromise of this particular component. So this is very, very substantial from a security perspective. Okay, so what exactly makes the Endian firewall vulnerable to command injection? Well, if you were to look at that particular script that's vulnerable, and you were to do a quick synopsis of it, you'd see that it takes in inputs just like our previous script that we described. And incidentally, it's Perl too. And it basically runs a series of input tests. Well, ironically, these input tests are really more functional tests. They're more like, do the passwords match? Is it a valid username type tests? But they don't actually sanitize these particular user-provided inputs before they pass them, you guessed it, to a system shell. Same exact thing that we did in our previous example. And you'll notice that username has a slightly different form here. It's referenced as a variable, whereas the new password field is pulled out as a CGI parameter. Actually, the username was pulled out as a CGI parameter the same exact manner earlier in the code, but it was essentially just to pull it out to check to see if that username existed in a database. And then they didn't bother to, call it out again as another CGI parameter. They just used the local retained value, which makes sense. But in any event, neither of these particular pieces of user-provided input are sanitized at all or validated. So in this particular case, what I did for this particular exploit is I send an encrypted packet to that particular firewall that is intended to test this particular exploit, or test this particular vulnerability, excuse me. But one thing I'm doing here is I'm using a very kind payload. I'm basically just, dropping a file in the temp folder called hacked, right? And I'm not doing anything else. Excuse me, I'm not doing anything else malicious to this particular firewall. It could be much more malicious, right? We could do a lot of different things here. So when I send this particular packet to the Endian firewall, again, using very similar techniques to what we just did earlier with our example, I've got a before and after screenshot here of what the firewall state looks like. So before the firewall, or before the exploit, when I list the contents of that temp folder, there's 3 items in that particular temp folder. And when I conduct the exploit, then I list those contents again, and you can see the presence of this new file called hacked, right, which is exactly what my payload was. And you can notice that it's also owned by the nobody user. For those of you familiar with Linux and Unix, the nobody user is essentially it's typically a low privileged user account that doesn't necessarily authenticate. You typically don't log in as nobody. It's really just there to kind of provide some basic functionality for the system. But one of the problems with this particular system, the Endian Firewall 2.5.2, that makes it excessively vulnerable is that this particular command injection exploit gives me nobody privileges on the box, or on the particular firewall. And so I can execute any of those commands with nobody within the nobody context, right? With the nobody user context. But what nobody actually has access to on this particular firewall is they can actually reset the root password, which is the administrator password, without authenticating. So they have access to a script that will actually allow that to happen, which is another issue of the defense in depth, kind of being lost here, okay? So that would be another vulnerability that we would want to look at and certainly understand, the architecture and the environment for secure coding as well. But that's a little outside the context of the command injection that we're talking about here. Okay, so this is obviously a bad situation. I can basically embed any kind of payload that I want that the system could possibly execute. So how do we go about mitigating this particular vulnerability? So the first step is, just as we talked about earlier, we're going to define and enforce input requirements. For this particular demo, we're going to limit the password to just letters and numbers. Okay, and that's just for example purposes here. Okay, we're also going to not try to force any kind of major design changes in order to handle this. And so the approach that I took with this mitigation is to just extend the existing error handling logic. Now, since I've mentioned limiting the password to just letters and numbers, I feel the need to insert this disclaimer here. A security mechanism really shouldn't restrict characters because it makes it hard to what we call brute force passwords. So basically just random guessing or iterative guessing, From a cryptographic standpoint, needlessly restricting characters available for a password would reduce what we call the alphabet size, and that would severely limit the numbers of combinations of different passwords that an attacker would have to guess. in order to be able to brute force a password. So it's bad practice to needlessly restrict characters. There's also potential issues with some characters to enter some characters on some systems. So, for instance, if this was a system that I was going to access from my desktop and also access from my smartphone, for instance, when I access from my desktop, I've got a full-size keyboard. I can punch in a lot of different characters that I may not be able to access at all or punch in, enter at all on a smartphone interface. And then, of course, there's other locale issues. There's a number of different issues that I may not be able to address there. So in some cases, I may need to restrict the number of characters. And all I'm doing with my disclaimer here is I'm recognizing that there's different approaches and different opinions on these particular issues. And just trying to ward off, I guess, some potential criticisms based off of saying, oh, okay, we're limiting passwords to just letters and numbers now. No, I'm not advocating that by any means. Okay, so for this demo purpose, though, that's what we're going to do. So here's specifically how you can go through and mitigate this particular vulnerability. It had that series of input tests that it conducted, where it's basically checking the functional tests. The password's the same, because I'm not going to let you set the password to the same password that it was already. Is the new password 1 and new password 2 fields, right? Because one of them is to make sure you punched in the password correctly, or do those match, before I go setting the password, because otherwise you're not going to necessarily know what that password is. So those tests are conducted, but then I'm going to add in a security test that's basically going to use that same framework for error checking, and it's going to restrict that input to only letters and numbers. And you see that the regular expression is actually even easier than the one that we had earlier. So in this particular case, I'm going to grab that new password parameter. I'm going to check the regular expression to make sure that it satisfies our criteria. It's basically all letters and numbers, ignoring case. And if you don't match that particular pattern, use any kind of special symbol or anything like that at all, I am going to basically trigger an error and state that in the error message that you entered an illegal character into the password. And then I'm going to go to the standard error handling framework that this particular firewall has. And then after that, I will go ahead and pass those particular parameters to the firewall, to the system shell on that firewall. Okay. And so what that does is now the hack attempts, when I try to hack this particular firewall again, what happened before was when I would send the hack packet, it would actually say that I successfully changed the password. Well, I did successfully change the password, but I also dropped that file on there as well. And so now when I try to do the same attack on the firewall, it refuses to execute those commands, and it basically says illegal character and password, which is the error message that I was including in my error handling function. And so one of the big considerations with this particular example is it kind of highlights the need for organizations to start adopting some of these secure coding principles, because what happened here is this is a security application that quite honestly missed some low-hanging fruit, let's just put it that way, as far as secure coding issues, and it left itself exposed to potential exploits, potentially simple exploits. And so it's important that organizations understand that it's valuable to go ahead and start getting users, developers, the appropriate tools that they need to write code securely. So there's a lot of static analysis tools out there that could potentially flag on this kind of information if you were to write scripts like this, that would basically say, hey, there's an obvious command injection issue with this code that you're executing. And to just get developers more informed as to what these types of vulnerabilities are and some of the best practices, so that they could potentially avoid developing software in this particular way. So that concludes the technical portion of the presentation, and we discussed some of these considerations as we went through the presentation. So that concludes the presentation. Are there any questions?
Okay, this is Steve, Tom. So thanks for the presentation. It was very interesting. We do have one question. If you could go back to the slide where you had the NIST vulnerability database and the common vulnerability enumeration slide. Okay, yeah.
Sure.
Okay, so so one of the individuals notes that people can tend to get confused between the NVD and the CVE, and then he also talks about the the CWE, the common weakness enumeration. That vulnerability tools assess for developmental software, and you did mention static code analyzers right there near the end. So could you maybe talk a little bit about the NVD listing specific COTS products and their CVEs versus tools to assess the code that you develop?
Okay, so the NVD will include specific COTS products. They'll include vulnerabilities for those COTS products and open source products. There's actually a lot of vulnerabilities in there that are attributed to Linux itself. There's a lot of vulnerabilities in there attributed to Microsoft Windows, and there's some attributed to Mac as well. So that's where the COTS products would certainly be listed. And the CVE tools, okay, so most of the tools are not going to detect CVEs. What they're going to detect is they're actually going to detect the common weakness enumerations, which are the CWEs. And those CWEs are essentially basically the patterns that most of those common vulnerability exposures are going to exhibit. So, for instance, in the case of the command injection, we would look for inputs that were taken from a user space, kind of a taint analysis, if you will, and we would check to see if they were undergoing any kind of validation before they're used, and that would be an example of how a static analysis tool might alert and say, hey, this particular input is taken directly from the user and there's no checks done on it whatsoever. And so that would be an example of that. I think that answers your question. But then the CVE is basically the NVD, the National Vulnerability Database, is composed of a bunch of best practices and stuff like that, and some documentation about vulnerabilities in general. And then it has a database of the common vulnerabilities and exposures, so the CVEs. Those CVEs will have the identifiers, the descriptions, et cetera, like we talked about. But they'll also, each one of those CVEs will also include a common vulnerability scoring system, impact score and impact assessment, which would basically tell you, hey, here's what that particular vulnerability means to you in terms of what the impact to your operations might be. The CWE would include some information as far as, hey, these are fairly easy attacks to execute. So that would be something else that you could potentially do as well, look at as well, because it's going to have additional information in it for the CWEs. But that's a great point to bring that out. Okay.
Thanks for working on clarifying those differences there. That is helpful. So thanks on that one. So there was we have another question, and this particular individual was wondering where you did your exploit. It says what was the packet that you sent to the server, and how did you determine the encryption that you utilized?
Okay, so what I did was I essentially looked at that CGI script, the vulnerable script, and I basically just called the script and looked at what the data was that it was outputting. That's essentially the data content of a packet. And so when I went ahead and tried to put in some command injection type stuff, that gave me the basic format for the packet. And of course, actually one of the things that I did specifically to capture that entire format was I used a proxy system. So I set up a proxy in between the interface to the web interface to the firewall and the firewall system itself. And I captured that data. I think it was the burp suite that I was using, burp proxy. So then from that, I had the actual packet that I could modify, and that's where I inserted the command injection type information and went ahead and saved that packet off as a binary, and was able to replay that using I forget if it was HPing or no, it was a netcat or a netcat utility that would work with SSL. So it doesn't take a lot to get the information for these particular vulnerabilities, not really. But it's most of the tools that you would use for developing these things are open source. They're freely available. There's a lot of documentation out there for understanding how to walk through some of these vulnerabilities. But the purpose of the webinar wasn't necessarily to turn everybody into a vulnerability expert, but an exploit operator or anything like that. But
okay, thanks, Tom. So, okay, Vigil has another question, and he asks, wouldn't single quoting command line arguments prevent the shell meta characters from being interpreted and executed as commands?
You very well could do that. Yes. But I think that would have. I think he's talking about would that satisfy my particular sample injection? Yes. I don't think it would have. It wouldn't have worked on the actual firewall though.
Okay.
Because that sends it bundles the information in a package or packet and sends it. So yes.
Okay. Thanks. Let's see. In your initial example that you gave, wouldn't it be possible to just filter out the semicolon character as a bad input?
Yes, it's certainly possible to filter out the semicolon input as a bad input, but if actually, let me go back to this one slide here. No, I'm sorry, wrong way. But yes, I could go through and I could filter out the bad input, but that'd be the approach of what we call blacklisting, which would be saying, oh, rather than me tell you what you can do, let me tell you every single thing that you could do that's bad. And the problem, the limitation of that approach is we often will miss some of the things that are bad. So for instance, yes, a semicolon could be filtered out, but there's also other characters that I could use that would do the same, have a similar result, such as ampersands and pipes. They come to mind. And there may be even others, and those are, the approach there is basically saying, I understand every single bad thing that could potentially happen. And in most cases, we don't actually understand every single bad thing that could happen. And so, rather than relying on things that I may or may not know, let me go ahead and define something that I do know, and that's what I expect this data to look like, and let me enforce that data looks exactly as I expect it to. And it's typically a safer option, safer approach.
Okay. Thanks. So I guess I just wanted to comment on the the example you gave there with the Endian firewall, and it just seemed like anything that could possibly go wrong went wrong with that. It's like the perfect storm of the security failures. It was just
right.
It was just quite remarkable. I couldn't. It was hard to believe as you were running through that example. Like it couldn't get much worse than that. So
it couldn't get much worse than that, Steve. That's a great point. And also, it's to show that this can happen to anybody, right? Because this is a group that's actually developing security products. And
right.
If they're missing that, what about developing security products and don't necessarily have all that training and background? what is our likelihood potentially of falling prey to these kinds of vulnerabilities? And that's where the tools and the training and stuff like that comes into play, where we should get educated on these things.
Yeah, no, like I said, it was very enlightening. Folks need to kind of be aware of this and start paying some attention to these things and trying to lock down these systems a little bit. Folks, there's a lot of folks out there that would like to get into your systems and for different reasons and different purposes. But once they get access, they can wreak all sorts of havoc. So the more we can do to prevent that from happening, the better off we'll all be. So. Let's see, we had another question just pop up, and the individual is wondering if there are any tools that you would recommend for doing that input validation process.
So there are some tools. Some of them are commercial tools, and one of the problems with the commercial tools is that they're for small office and small businesses. You could say that they're prohibitively expensive, as in, more than $10,000. There are some tools, though, that are freely available, and there are varying degrees of effectiveness. Let's say it that way, perhaps. But there's, one that comes to mind that I've used recently is the Clang Static Analyzer. It's a free tool that's it has some security checks that it will do. Of course, it's a limited set of checks, but just to kind of start getting into the mindset of, hey, here are some ways that we can secure this, and that's an open source tool, incidentally, and it's something that the community could certainly contribute back to, which would be a good idea. And there are some other tools that are specific to languages, such as the University of Maryland has one tool, Find Bugs. It's basically a plugin for the Eclipse IDE. So if you're using Java and you're using the Eclipse IDE, Find Bugs would be a nice free tool potentially to use that will find a lot of these types of vulnerabilities, buffer overruns and stuff like that. But it's really something that you just need to start getting familiar with, kind of get it into your integrated development environment and start playing around with some of that as well. And there are a number of commercial tools out there, but if you Google secure coding tools, you'll find a lot of them. Okay.
And just point out there. One of our attendees has kind of shared a comment on one of the earlier questions, the one regarding using a semicolon as a bad input, and the individual is just pointing out that you can also sometimes use other characters, Unicode, hex, in place of the semicolon. So just let folks, wanted to let folks know about that as well. So.
Right. Different encodings for those. Yes, sir.
Yep. So, if there are no other questions for Tom, Tom, if you any closing remarks that you have, or if not, we'll just wrap up here.
Well, I would just, in closing, I'd just say, thank you for the opportunity. I appreciate CSIAC giving me the opportunity to give the webinar. I hope that it was useful and for people. They found some value in it, and would encourage them to start trying to, like we said, pursue training options and also, start using some tools that would potentially help with this particular issue. Because there's an awful lot of vulnerabilities out there in the National Vulnerability Database, and even ones that aren't there because they haven't been reported yet, that could be completely prevented by just starting to adopt some of these secure coding concepts and principles. And that's a vision of software that I'd like to see happen someday, where we actually start to get past some of these For instance, buffer overruns, they've been around for decades now, but they're still, plaguing the industry. It'd be nice to see that go away eventually in time with better tools and better education. But thank you again.
Okay. Well, thank you for your time and sharing this information with us. It was very it's very critical topic and valuable information, and we appreciate you sharing the information with our attendees. So, with that, I'd just like to thank everybody for attending, and we'll hope to see you at the webinar next month. So, have a good day, everybody. So long. Bye bye.